All right, so let's start. How many of you already know C? Show of hands. Like really know, like program constantly in C. You do hardware?
I'm in Sterling's class.
Unix.
Yeah.
Okay, but have you ever worked on like a huge project?
I mean, Sterling first homework is pretty huge.
Right, but that's very it's very condensed. I'm not asking like if you write like Linux drivers for Linux, Linus. Put your hand down. But yeah, okay. So yeah, it's very easy to just know C, but there are it's more of like you have to do something to really learn it, and C is just one of those languages. The overview. So we're just gonna go over something quick and see just enough to understand like a buffer overflow. Anyone know what a buffer overflow is? Show of hands. No? All right, that's great. All right. Yeah, so buffer overflow, that will be at the last part. So C is a compiled language, which means like your source code gets translated to machine code. And what I mean by machine code is, so your CPU has like an instruction set, and the source code is being translated into instructions for that CPU. So that means like if you have source code for a specific architecture, it has to be recompiled for a different architecture. Right? So C is fast, and it's very low level, so very low abstraction. All right, so these are the data types. Anyone can tell me the sizes of them are? Rashik? Okay. What about char? 1 byte? Yep. Anyone can tell me size of a short? 2 bytes? Okay. I don't expect anyone to know the rest. Floats are ugly. All right, Josh, go. Float. Double? Yeah, well, it's double. No. That is the next slide. So a pointer holds the address of a piece of that cut off data. So these are your data types, right? So a pointer will just hold the address of where this is in memory, right? So I have this function. I declare an int count, and I declare an int pointer by specifying the star. The ampersand will denote the address of count, so this pointer will now point to the address of count. And the star will dereference it, and it will write to where the pointer is pointing at. So it will essentially assign 0 to this int. And these are some input calls, some I/O. So scanf, gets, and fgets are like C standard library calls for I/O. And yeah, you got the system call reads. Okay, next. So like you also have like output, like printf, generically used just to print a string, and then you have format. The dot dot is like variable arguments. So the format string will take in like a % and like some letter, and that'll denote like, oh, a format has to be specified for this string. So it'll grab one of your variable arguments, place that into there, and it'll print it out. And puts will just take a string and just print it out to the console. Same thing. Well, write is the system call version for that. All right. So C strings are strings in C. C strings are just like an array of chars, right? So a char is 1 byte. It denotes a single letter or character. So a string in C will be just like those chars, like consecutively in memory. So you have a string, you just allocate just throughout that array. And yeah, so C strings are generally denoted by the null byte at the end. So like general functions in like the C standard library they expect you to have a null byte. Otherwise, things will get crazy. Questions so far? Following? Okay. String manipulation is done in string.h. This is one of the header files. You could probably look it up. You look up like the string functions. And okay, so this, just knowing that, we're gonna go like a little bit higher level. So whenever a function is called, a frame is placed into memory, and successive function calls will like place their own frames on the top of memory. So it keeps track of the most recent function that is being called. So anyone know what kind of data structure would that be used? Anyone? Sheik? What data structure does that? Keeps track of the last thing, and just and then it takes it off once it's done.
Stack.
Right, stack. So memory is going to be, the data structure that is keeping track of local variables, whenever you call a function, right, and you have some local variable declarations, it's going to allocate some memory by incrementing the stack and then placing the parameters within that stack frame. And then once that's done, it's going to remove it, and you're going to be back to where you used to be, right? So that's how you keep track of main. Main calls func1, passes the parameters through the stack, and then once that's done, that gets removed and back at main. Keeps track of a whole chain of whatever you're calling, and you can come back safely. All right, so this will be the start to go into the buffer overflow part. So when you allocate a local variable, you're basically in that stack frame, right? You're declaring this 4 bytes size of an int, and you're setting it to 0. So the 4 bytes in memory will be set to 0. So what happens when you allocate a buffer of size 200? That gets placed directly under that that int, right? So string copy. Anyone know what string copy does? Yep. Yeah. So this is dest. This is source. Source is getting from something outside of this function. That's probably going to be passed in through the stack. So string copy, do you know how it knows when to stop? Yep. Right. Null byte. That's how. That's what's expected of C strings. So you pass in the string, right? And you're writing it to a buff, and the buff is of size 200, right? So you're basically writing in your bytes throughout this buffer, right? But the question is how do you know when to stop? It stops towards the null byte, right? What if the null byte is bigger than 200, right? You start writing past that int. You just declared. You just change the value of that int, and essentially you just write past your own your stack frame for this function, right? So what I didn't tell you yet is that whenever a function is called, the return address is basically placed on the stack, so you know when to return to. So right, C strings and the null bytes. String copy will iterate through a pointer until it finds this null byte, and the 200 character buffer is allocated, and string copy doesn't care what size your buffer is. It just looks for that null byte. It'll keep writing, and you can basically corrupt anything that's currently on the stack. So you can basically overwrite any metadata, such as the return address and other arguments that are passed in, right? That's what's called a buffer overflow. Yeah, buffer overflows are one of the baby's first things to learn when you're exploiting something. So what else I have? Right. So a right axis violation occurs. Anything so you basically, it doesn't necessarily have to be within this function stack frame. You can have the previous function stack frame here, and you could corrupt past that. You basically just linearly write through everything on memory. But just know that when this function returns, it'll try to take this return address and try to return to this instruction. And you control that because you're basically writing past this whole buffer. All right, so the return address holds the address of the previous calling function, right? So that's not to be confused with, like return null when you write in source, right? So what that does is it tells it to move null or 0 into a CPU register to be kept for when for the calling function, and then get the return address and then return. It's not necessarily the same as that, but it just tells it to leave this stack frame. So how do we take control of the binary? So if we overwrite the return address, we can direct control of the program. The address should be something that we control, like i.e. the buffer. And then like we place our shell code or the machine code, whatever code that the architecture that the program is running on, into the buffer, then we can have the code execute, right? Then we just jump into the buffer and we can execute our own code instead of what it's supposed to do, right? So what do we want to do? Usually like people want to get a shell. So we need to have the shell code equivalent of this call, right? Exec bin sh and the null byte. That will call the shell, right? It'll spawn a shell even though this program wasn't supposed to. And probably, whatever you want to do after that, that's up to you. Okay. So any questions so far? Yes.
How do you know where in, or how do you direct it to a specific point in memory where you know, like, what you want to execute is like located?
Okay.
And how do you know that you're at the end of the string also? Because you said it's an array, so I'm assuming you know exactly where that array ends.
Right, but that's the thing. Sure copy doesn't care where that array ends. The array ends wherever you specify it to be. Right? And what else was the other question? You said, how do you know where to jump to? Right?
Well, I guess that kind of went hand in hand.
Okay, but that's like a common thing because it's kind of difficult to talk about like these old bugs, even though they're not necessarily old, they still like appear. But modern day protections, they have like address space layout randomization, so the buffer will change every time. But with what it used to be in the old back in like the 90s, the buffer would not change addresses. So you would know where to jump to. You would just hard code an address and jump to there, right? But nowadays, that address is changed every single time. So now you have to sort of have a leak, someone tell you, or you have to gather some information about the environment of the program, right? Any other questions? Yes? No? Sure? All right, so so there is a demo set up at this IP address. So you guys can like, if you go to port 80, so if you like open it up in the browser, you can grab the binary and just like look at the source code. And let's see. To exploit it, I have the service running, so you can netcat to that same service on port 1337. So let's see. So that's going to look like this. Yeah. So that's the service. It's going to like say welcome, and like you said, right? How do you know where the buffer is? So I've deliberately like left the buffer's address here, so you know where to jump to, right? So like it'll just take some input, and it'll say bye. Yeah, do you guys like want to work on it, or should I like walk through how to exploit it? Yes. Huh? 1337. I mean, I can, yeah, hold on. So like I already wrote the exploit for this. So like I'll show you how it works. You guys want to see? So like the exploit is just a Python script. Right? So this is the shell code that will generate the shell. This is the length of the buffer that I have to write up to, the IP. And these are just some receivings so I can get the leak. And then I just send enough up to the return address to overwrite it and then have it jump to the buffer. So I'm receiving that line that it's spitting out to buffer address, and then I'm overwriting up to the, where is that? Yep, I'm overwriting up to the return address, placing that buffer address, and then jumping into the shellcode. So when that shellcode executes, it's going to launch me a shell, right? So I'm just going to execute the script, right? Boom, shell acquired. So now I have like access to this box, even though I shouldn't be, right? So like I have another program here, which is Vuln2. It has the set user ID. Anyone know about like file permissions here? Yeah. Yeah. You know what the set user ID does? Yeah. So like what happens is when you first get the shell, you might not have enough permissions to like work around this like machine. So you want to have like some privilege escalation. Yeah, you got a question? Yes. That is the set user ID bit for this binary. So you see how this binary is owned by John? So like with the set user ID, when this is run, you will basically become John, I guess. Like you'll have access to what John has. So like essentially this binary is just like a privilege escalation example, because really when you escalate your privileges in like the real world, you have to find some like kernel vulnerability or something like that, right? So you can get root, and then once you have root, you can have access to everything. But like, yeah, once you have access to the box, you just like escalate your privileges, right? And now I'm John, right? Now I can go to John's directory and cat his like secret file, I guess. Which is a toucan. So like, you guys working on it, I guess? I mean, because, I don't know, that's it. Any questions? Yes? No? Yeah, sure. Yeah. So, I mean, let me walk through